Hi. So I'd like to talk about three types of scenarios that we have when we're talking about systems of linear equations. Linear, again, means straight, a straight line equation. So when we're dealing with a system of equations, we're dealing with two straight lines when we're dealing with linear systems. So there's three scenarios that can happen. And each one of these scenarios we're going to be using some vocabulary terms with. All right. So the first scenario that we have is when we have two straight lines that cross at one particular point. So if these two lines cross at one point, that means they share a common solution. All right. When they share a common solution at this point right here, let's call this x comma y. This point right here has an x value and a y value that if we plug them into the equations, not just of one of the lines, but both of the lines, that would solve both of those equations. And so therefore, this is a common solution for these two linear equations. There's two vocabulary words that I like to talk about with this. The first vocabulary word is that this is called a consistent equation or a consistent system of equations. Consistent. So the vocabulary word consistent means that two lines share at least one common point. Consistent lines, or a consistent system of equations, is a scenario where the two lines share at least one common point. That means one or more common points. If that's the case, then we call this system consistent. The second vocabulary word that I like to use is independent. This system here has two independent lines. Independent. So independent lines are two lines that have their own separate equation, meaning that the equation of this line is different than the equation of this line. In some way, either the slope is different, or the y-intercept is different, or both the slope and y-intercepts are different. So independent lines have different equations. In some way. In any way. It could be the slope, or it could be the y-intercept, or it could be both. Since these two lines have different slopes, do you see that this line right here must have some sort of negative slope, and this line right here, because it's going up, must have some positive slope? That by itself is enough for us to conclude that these are two independent lines. On top of that, they also happen to have different y-intercepts. Let's say the y-axis was right here. This line crosses the y-axis here, and this line crosses the y-axis here. And so they're also different y-intercepts. But even if they just had different slopes, but the same y-intercept, that would be enough for them to be independent lines. For instance, what if I said that the y-intercept went right through here? Do you see that these two lines would then have the same y-intercept? Just happens that the place that they meet also is on the y-axis, but they would still be independent because they have different slopes. All right? So as long as the slope is different, or the y-intercept is different, or both, all of those cases are independent lines. Therefore, when you have a system of equations where they cross at least one point and they have different equations, we will call this scenario both consistent, and independent. And that is the first scenario. In the next video, I will show you the second scenario.